All right, in this video, we're going to determine whether two events are independent or dependent. Now, how that works is if two events are independent, so two events A and B, if those are independent, then you can say and do PA times PB. So the probability of A and B should equal the probability of A times the probability of B. So these should be equal if you're independent. If the left and right are not equal, you are not independent, which makes you dependent. So let's look at an example. So a vase contains 3 white roses and 1 red rose. You randomly select 2 roses to take home. Use a sample space to determine whether selecting a white rose first and randomly selecting a white rose second are independent events. So we're eventually going to use this, but before I get there, I want to draw a picture and figure out what this sample space looks like. So we're selecting 2 roses to take home. So let's first look at that first rose. So when I select that first rose, I have to choose from 3 whites and 1 red. So I'm going to break this down to, I could have W1, W2, W3. Now the reason I did white 1, white 2, white 3 is the white roses, I mean, you've seen flowers before, they all don't look exactly the same. So this is going to designate this first white rose, that second white rose, that third white rose. So 3 different options. And I still have that other option, which is that 1 red rose, so I'm just going to put an R for that. So I select my first flower. Those are the 4 options on the table. Now let's look at selecting that second rose. So that's the second thing we're doing. So say I selected this white rose 1 first. When I'm selecting my second rose, my options are, well, I can't pick white rose 1 again because I already have that. So my options are W2, W3, and R. So the second, third, and red rose. Those are my options there. Because white 1 is taken away, I only have W2, W3, and R available. If I would have selected white rose 2 the first time, my options are, well, I can't select W2, but I can get W1, W3 in red for that one. Notice how 1, 2, and 3 in red are all there, but I can't have the second one available over here because I already got it. Then we have W3, so I can do white 1, white 2, and R. W1, W2, W3. So if I had the rose first, the red one, my options are W1, W2, W3. If I picked white rose 3, then I only have 1 and 2 available in R. So you can kind of see how that's playing out. So what I'm going to do is I'm going to write out my sample space here. So I could have W1, W2 as my first and second rows, W1, W3, W1, R, W2, W1, W2, W3, W2, R. Down here I could have W3, W1, W3, W2, W3, R. And finally R, W1, R, W2, and R, W3. So this is for selecting the first 2 roses, my first one and my second one. So the total options I have is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 outcomes available. So I have 12 outcomes. There's my sample space. So I can finally get to the question here. They want us to determine whether selecting a white rose first and randomly selecting a white rose second are independent. So what I'm going to do is, this is the rule if you have 2 independent events. Probability of A and B should equal the probability of A times the probability of B. What I'm going to do is I'm going to rewrite this, but replace A and B with the 2 events I'm looking at. So I'm looking at selecting a white rose first and selecting a white rose second. So white rose first will go in for A, white rose second will go in for B. So in words, I'm going to write this on the bottom. We're looking to see if probability of white rose first and white rose second is the probability of white rose first and white rose second. Is that equal to the probability of a white rose first times probability of a white rose second? So is this equal to taking the white rose first multiplied by the probability of white rose second? So I'm going to figure out each of these. I'm going to figure out this probability, that probability. 3 different ones I'm going to calculate. Multiply the right side and see if it's equal to the left side. So I need to figure out what's the probability that I have a white rose first and a white rose second. So from earlier, we figured out there's 12 total outcomes. So I'm going to count up how many different outcomes do I have a white rose first, white rose second. Things to know is the white rose first, white rose second. That doesn't mean W1, W2. It just says any white rose first and any white rose second. So W1, W2, W3, W1, W2, W3. So let's count up how many different ways do I have a white rose first and a white rose second. So 1, 2, 3, 4, 5, 6 times out of 12. And we want to know, is that equal to this right side? So over here, let's figure out how many times do I end up with just a white rose first. So of all the outcomes, let's count up how many times is there a W in the first slot. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that happens 9, and we said there's 12 total outcomes. And then a white rose second. So I'm looking in the second slot, count up how many times do I have a W in the second slot. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 out of 12 over there as well. And what I want to do is multiply those together. Because it's hard to compare fractions. Let's get the decimal version. So 6 over 12 is 0.5. Over here in a calculator, I'd take 9 divided by 12, multiplication sign, 9 divided by 12, hit enter, and what you get is 0.5625. So notice that these two numbers are very, very close, but not quite the same. Since these are not equal, we are not independent. So after all that work, we now know selecting a white rose first and randomly selecting a white rose second are not independent events, meaning they're dependent. They rely on each other. Depending on the event that happens first, it will affect the second one. And that was determining independent or dependent events.